You run out of glucose because ultimately those glycogen stores get depleted. This is a picture of somebody experiencing, in marathon language, what's called hitting the wall. Usually occurs around mile 20 of the marathon. What happens is your glycogen stores have been depleted. What you need to do is, well, I've been told that it's like running on fumes. Whatever the person is able to get from the stands that they're running past, a sports beverage, the glucose gels that people carry with them, that's what's providing them with the energy to complete the marathon. In order to maximize your glycogen stores, it's recommended to have a high carbohydrate diet, about 8 grams per kilogram body weight. If you are involved in an activity that goes for longer than 45 minutes, this is when I recommend sports drinks. We'll look more in class at what makes up a good sports drink, how much carbohydrate, how much electrolytes should be in it. But if you can't afford a sports drink, then dilute fruit juice. Yes, I am saying fruit juice. Will also provide you with the carbohydrate your body needs. During activities of greater than 45 minutes in duration, it's recommended that you consume light carbohydrate snacks, about 200 calories or less. More than 200 calories means that your body is going to be spending a lot of time digesting when you want something that can quickly be broken down and released into the bloodstream. After the activity, high carbohydrate meals within 15 minutes have been shown to increase your glycogen stores by up to 300%. If you can't eat right after an activity, and many people can't because the body is just in a state of exhaustion, then a high carbohydrate meal within 2 hours helps improve the ability to store glycogen. Fat use is affected by the duration of the activity, the intensity of the activity, and how well trained the muscles are. After about 20 minutes, fat becomes the major fuel that the muscles are drawing on for energy. Increasing intensity causes the muscles to return to glucose for energy. So understand that 20 minutes, by definition, means that we're talking about a lower intensity aerobic activity. We need oxygen in order to break down fat. So the activity must be aerobic in order for fat to be broken down. The better trained muscles use fat more quickly, thus preserving our glycogen stores. Let's just take a quick look at this slide. I'm going to go over it more in class. What I want you to notice in this graph is that activity uses both carbohydrate and fat for energy, but as the duration increases, the carbohydrate stores start to go down as we deplete them, and the amount of fat that's being used for energy begins to increase. What trained muscles are able to do is push this back so that you start drawing on fat much more quickly. Again, we will look at this in more detail in class. Protein synthesis is suppressed during activity, and then it begins to accelerate after the activity is completed. When you exercise, your muscles may actually be damaged as a result of the activity, particularly anaerobic activity like weightlifting. That tissue needs to be repaired after the activity. So your body produces hormones that suppress protein synthesis while these cells are being active, and then allows protein synthesis to begin once the activity is over. Intensity and duration of activity affects protein use. If glycogen stores are depleted, then your body will rely more on protein for energy. And training affects protein use. The more well-trained the muscle, the less protein used for energy. As we've said previously, the more trained the muscle, the more quickly fat is used for activity, and the better equipped the muscles are to preserve glycogen stores. Protein needs for fitness, it's not as much as most people think. If you look at the chart on the left, the most elite of trainers, bodybuilders, strength athletes, less than 1 gram per pound. Muscles grow in response to being used, not in response to eating protein. Eating protein doesn't make muscle. This chart goes through the different fuels used for activities of different intensity and duration. Please have a look at it, and we will review this again in class. What I want you to pay attention to in this chart are which activities are aerobic, which activities are anaerobic, the intensity and duration of the activities, and we'll talk more about which fuels are used during those activities. So for class, I want you to give me an idea of your own personal activity plan that you've put together. We will review the materials in this screencast, particularly when we used fat and carbohydrate, as well as the chart we just looked at, and we'll continue discussing the importance of fluids and electrolytes, the importance of hydration. Thank you.